Hi guys, Mr. Whelan. I'm going to go through the solutions to this paper now so that we can see what the answers are. Okay, just a quick note, remember if you are doing a diagram, do it in pencil. I'm going to do it in pen so you can see what I'm doing. Okay, without much further ado, the only other thing I'll say is this is paper 2H, so there's no reason why you shouldn't be using a calculator for any of your calculations. Okay, so I'm going to get started then. So we've got this scatter graph, okay, we get the information about it at the top. I'm just going to go straight to the information I've been given. So Chicago is a city in the USA. Chicago is 4,000 miles from London by drawing a line of best fit. Right, if you're ever estimating from a scatter graph, guys, just draw the line of best fit. It makes your life so much easier, okay? So I want a nice line that goes through all the points here, okay? And I try to make my life as easy and straightforward as possible. Okay, I want to follow the pattern of the points as best I can. So I'm thinking something like that. Okay, I'm passing through as many points as possible, following the pattern of points. Doesn't have to go through the origin. You can see mine misses it there. Okay, and then without further ado, we're going to get straight into it, guys. I want the time taken to fly from London to Chicago, and I was told it's 4,000 miles. So I'm going to get to 4,000 on the distance scale, guys. Go straight across, drop straight down. Do please draw this on there, guys. It makes your marker's life so much easier. I'm going to read off the scale. So 460, 470, okay. 480, 490, so I've got 495 minutes. Why is this only an estimate? It's only an estimate because it's a line of best fit, and lines of best fit are estimates, okay? So I'm just going to jot that straight in there. All right, remember, a line of best fit, guys, is different for everyone. Speaking of that, guys, what that also means is that answer above, the mark scheme would have allowed you to have anything from 480 to 500 in there, okay? So that was your allowable sort of range of error there. And similarly, guys, on the gradient one below, there'll be an allowable range of error, which I'll talk about in a minute once I've got there, okay? So what I'm going to do now, I'm going to try and work out the answer to that. So I need the gradient calculations, okay? So I need vertical change divided by horizontal change. So I'm going to draw a right angled triangle on my graph. When I'm picking these points, guys, I pick that one because it's a nice, easy grid point to measure, okay? It's 495, and I've managed to hit this point perfectly. So I'm going to definitely pick that one because it's, again, making it easy for me to count my numbers, okay? So I've got 500, I've got 500, and I've got 400 there, okay? So I know my vertical change is going to be 1,400. And again, if you're writing this on the graph, guys, there's no problem with that. The examiner is going to see it, okay? All right, going across then, I've got 50 there, I've got another 50 there, okay. This is then going to be 40, and I've got an extra 5 there, so I've got 145 as my horizontal change. So my gradient is going to be 1,400 divided by 145, okay. So 1,400 divided by 145, I'm going to turn that into decimal, and I get out 9.655172441. I'm going to stop writing, guys. I've made my point. It's 9.66 to 3 significant figures. If you're ever in doubt, guys, round it to 3 significant figures, but always write down the full answer there. And you're actually allowed anything from 9.4 to 9.8, guys. Anything within those margins would have got it there, okay? So, give an interpretation of the gradient of your line of best fit. Well, I've got to do a bit of thinking here. Now, I had a distance up the vertical axis, okay, which was then divided by a time, because that's what my horizontal axis is. It's time taken in minutes. Distance divided by time, guys, that's a speed, okay? So this is a speed, and I'm just going to make sure the examiner knows I understand this, because it was miles that I divided by minutes. So it's a speed in miles per minute. Okay, guys, and that is literally it. Whenever you're asked to interpret a gradient, say what it means in the real world. Think about the units is my advice. Whatever that is, okay, will help you out there. And that's question 1 done. Right, on to question 2, okay? So question 2 asks us to rotate shape S 90 degrees. I'll zoom in a bit now I'm done mucking about that graph. Clockwise around the centre 5, 4 and label your image T. So to do this, you'll need a piece of tracing paper. You can always ask for it in the exam. Here's one I prepared earlier. Don't let the wobbly lines fool you, guys, okay? Well, you do need to use a ruler when it's got a straight edge, and I'll show you what I mean by that. So I've just sketched it on there roughly, okay, and I'll get it lined up. Right, you might be struggling to see that through the camera. 90 degrees clockwise, so clockwise, same way around the hand's got a clock, so 90 degrees round, okay, and there it is. So I'm just going to make, I've got a point there, I've got the other point is down there, and then just get that back on there to line up the last point, and it's there. So again, take my ruler, okay, and I'm making my life harder, guys. I've only got a short ruler, okay, I think I lent my long ruler to someone and they've wandered off with it. And there's my label my image T. If you're asked to label it, guys, please do make sure you label it, okay? So that's that one done then, okay? Describe fully the single transformation that will map T onto S. So when I did that one, I went from S to T. So T onto S, okay, that's the order I'm going at. So I'm starting at T, okay, and I'm ending with S. That's the aim here, all right? So if I think about this, okay, it's going to be a rotation. And it's going to be 90 degrees anti-clockwise because I want to go backwards, so I'm in the opposite direction. And I'm going to use exactly the same centre, okay? So I've got a centre of 5, 4. You could get away with here, instead of saying 90 degrees anti-clockwise, saying 270 degrees clockwise, okay? The only time in a rotation I don't care about the direction is if I'm doing it 180 degrees, guys. Okay, that's question 2 done and in the bag there. Okay, happy days. Right, on to question 3 then, okay? So question 3, here are 2 rectangles. All the measurements are in centimetres, good, I've got no converting to do. The area of rectangle A is equal to the area of B, okay? Work out the perimeter of rectangle B. So I've got quite a lot of work to do here, and it is worth 5 marks. So the first thing I do know is the area of A is equal to the area of B. So, area of a rectangle, base times perpendicular height, 4x times 2.5, well 4 times 2.5 is 10, so that's 10x on that side. This side then, I've got 7 multiplied by 2x take 3, and actually it's not simple as that side, so I am going to expand that. So I've got 14x take 21. I've now got an equation to solve, okay, so I am going to take away 14x from both sides. Okay, you could do this several different ways, guys. There's lots of different ways to solve equations. So I've got negative 4x equals negative 21. So x is going to be 21 over 4. That's not so useful to me, so I'm just going to work that out on a calculator. Okay, or 5.25 centimetres. If you don't turn it into a decimal, guys, there's no problem with leaving it as 21 over 4. But the reason I wanted it on its own is I can now work out what this side is. So this side is 5.25. 2 times 5.25 take 3. So 2 times 5.25 is that. Take away 3 is that. So that's going to give me a side length of 7.5. And the reason I want to know that side length is I want the perimeter of B. So if I know the perimeter of B, the perimeter is all the way round. So I've got 2 sides of 7 because I have a 7 there. That's 7.5 as well. So I'm going to add up all those side lengths, okay. And then 7 adds 7 adds 7.5, add 7.5 again, out the far end comes 29. So the answer is 29 centimetres. Okay, and there we go, guys. So that's what I did. 5.25, 7 add 7, add 7.5, add 7.5. Okay, I'll zoom out a bit so you can see the one. Cool, that's question 3 done, in the bag. Okay, right, on to question 4. Okay, so the diagram shows a 4-sided spinner. Hasmeet is going to spin the spinner twice, complete the probability tree diagram. So there's 3 ways out of 4. I am told it's fair, so I know this works. So 3 of the 4 chances are to land on A, 1 of the 4 is going to land on B. The first spin will not affect the second spin, okay guys? It's not like I'm taking balls out of bag and they're not being put back in, or counters out of pot, or whatever else they talk about, or sweets, or anything like that. That's contained, okay? So work out the probability the spinner will land on A on the first spin, and land on B on the second spin. So it's 3/4, and that and is telling me that I'm going to multiply it by 1/4, okay? Again, calculator paper, if you're not happy with your fraction work, okay, use the fraction button on your calculator to work it out. It's going to give me 3/16. I can quite happily leave it as 3/16 there, okay? You might turn it into a decimal, but you're not going to get any bonus marks for it, okay? It is 0.1875. Okay, as a decimal, all right? But there's no need to. The fraction is perfectly good there. Okay? On to question 4. Okay? Sorry, that was question 4. On to question 5. Okay? Right. Question 5 then. S equals pi squared times b squared take a squared. That's a nasty formula. A is 8, b is 10. Calculate the value of s. So, first thing I'm going to do, I'm going to show my substitution. So I'm going to show that I am putting the numbers in the right place, because that will be the first mark in the mark scheme. Okay. I'm then going to make sure I type the thing in correctly. Okay, and I'm going to take time here. All right. This is where people will rush, make stupid mistakes. Pi squared, 10 squared, take 8 squared. Yep, that's all right. I'm going to press equals. Right, 355.305758. I'm then asked to round that to 3 significant figures. Always write down the unrounded answer, guys, but to 3 significant figures, that is 355. So I'm just going to drop that into the answer space there. Question 5 done, guys, okay? Can't underestimate enough. Show that substitution, show unrounded answers before you round, okay? Right, question 6. Only blue and white vans are made in a factory. The ratio of the number of blue vans to white vans is 4:3, so I'm just going to put that there. Write down the fraction of the vans that are blue. Well, there are 4 parts of the ratio of blue vans. There are 7 parts in total, so the answer is 4/7, okay? If you were to draw it as a bar model, okay, you would have 1, 2, 3, 4 bits that are blue, and then you would have 3 bits that are white, and you can see for yourself then is 4/7, okay? For blue vans, the number of small vans to large vans is 3 to 5. Work out the fraction of the number of vans made in the factory that are blue and large. So I know that 5/8 of the blue vans are large, okay? Now what that means is, because I want a fraction, that means it's 5/8 of 4/7, which is the same as 5/8 multiplied by 4/7. So literally again, onto the calculator, 5/8 multiplied by 4/7, okay? My calculator is going to tell me that it's 5/14, okay? There's no need to do anything else clever there, okay? I've literally made the calculator do the hard work, all right? The clever bit there was realising that it's 5/8 of the 4/7 that I've already got. Sir, I got my 4/7 wrong. Then you get a follow through mark, guys, for using the wrong number in the right place, okay? As long as you've multiplied it by 5/8. All right? On to question 7. Okay, find the reciprocal of 5. So remember, reciprocal, as soon as we see that, we're thinking 5 to the power of -1, okay? That won't get you the answer, though. What will get you the answer is writing it the other way as 1/5, or turning that into a decimal, okay? You have got a reciprocal button on your calculator, guys, okay? On this one, it's there, okay? I've got a little x to the -1, all right? Using your calculator, work out the cube root of 5 multiplied by the tangent of 60 degrees plus 1. Write down all the figures on your display. Just a reminder, guys, your calculator will put brackets there around the 60 degrees. Okay, so I'm going to type that in, making sure I get it correct. So cube root of 5 tangent of 60 plus 1. Notice if I don't put that second bracket in there, guys, it's all going to go wrong. Okay, I'm going to press equals, all right, and out's going to come in my answer, which is 2.129754359. Okay, I was asked to write everything down, so I did. Okay, and that's the end of question 7 there. So question 8 then. Make t the subject of p equals the square root of a add t over 2. So first thing I'm going to do is I'm going to square both sides. All right, there's not really an easy way of writing that. So that means that becomes p squared, and that becomes a add t over 2. The next thing I'm going to do is I'm going to take away a from both sides. So I'm going to have p squared take away a, and it's just like solving an equation, guys, only one of the sides is not getting smaller. Things are moving around. And then going to multiply by 2. Okay, and I'm going to have 2 lots of p squared take a is equal to t. And you might expand that, okay, you might have expanded it as you did it. There's no real reason to, but either of those is fine, okay? I'd have just stuck with the first one. All right, I'm not going to do extra work that I don't need to do, okay? And that's question 8, guys, changing the subject of a formula, okay? Quite a nasty one, but not too bad. On to question 9, okay? So, in the diagram, ABC and DEFG are parallel lines. Angle ABE is X. Okay, yep, that's there. E to B and E to F are the same. I need to show that W is 90 plus a half X. Give a reason for each stage in its working. Now, show that means, guys, I can't use this until the very end. I've got to prove that's true. But the first thing I'm going to prove is that Angle BEF, okay, is equal to x. Okay, I'm then going to mark it on the diagram. All right, now it says give a reason. Okay, so I must say why, and it's because alternate angles are equal. All right, so my next step then is I'm trying to think, I've got to head towards W. I can work out this angle here. I can do that because I've got a triangle and it's isosceles, okay? So I can do two things at once here. I've got angle, that is going to be BFE, okay? So angle BFE, so that's 180 degrees, take away x, divided by 2, okay? Now actually I'm going to tidy it up a bit here. That's 90 take away a half x. Okay, 180 divided by 2 is 90, and then x divided by 2 is a half x. Okay, and I can say that because isosceles, okay, because they told me it's an isosceles triangle because I've got two sides the same length. Triangles have matching base angles and sum to 180 degrees. Okay, so that's my job there. Okay, angle BFE, 180 take x over 2, it's 90 take a half x because isosceles triangles have matching base angles and sum to 180 degrees. Okay, so I now know what this is. This is 90 take a half x. So my last bit then, guys, all right, I know what W is. W is going to be 180 take, now I'm going to have to put this in brackets because I'm taking all of it, half x. I'm going to do a little bit of algebra here. So take 90, negative times negative becomes a positive. Okay, so 180 take 90 is 90 add a half x. Okay, and you'll notice I've got myself there. That's what I had to get to. Okay, I've got to give my reason though, or it's worthless, and it's because adjacent angles on a straight line sum to 180 degrees. Okay, and with all of that, that's done. It's 4 marks, guys. Okay, that's quite a big question there. If you don't give the reasons, you are not going to get the marks. It doesn't matter how clever you are. Okay, I've got to have all of those reasons in there. Okay, and that's question 9 done. All right, quite a long question, but not too bad. All right, on to question 10. In 2016, the population of the UK was 6.5 times 10 to the power 7. Laura wants to calculate an estimate for the population of the UK in 2020. She assumes the population increases by 0.6% each year. As soon as I see that, guys, by 6% per annum per year, I'm thinking compound interest. So using her assumption, calculate an estimate for the population of the UK in 2020. So that's 6.5 times 10 to the 7. So my multiplier is 1.006. Okay, because I'm thinking it's 100.6% because it's the 100 and the 0.6. Okay, now I've got from 2016 to 2020, so that's 4 years. So that's to the power of 4. Okay, so 6.5 times 10 to the 7 multiplied by 1.006 to the power of 4. Okay, now my calculator is going to give me 66,574,096.24. Now there's 2 problems with this. One, I started in standard form and I should really finish in it. It hasn't told me to, but it's kind of good manners to give things back. Secondly, it's an estimate, guys, and that's a very, very accurate estimate. So what I'm going to do, I'm going to round that to 3 significant figures and I'm going to turn it into standard 4 at the same time. So it's 6.66 times 10 to the power of 7, okay? But they haven't told me how I have to give my answer, so I've got a bit of freedom there. Part B, Kieran also assumes that the population of the UK increases by 0.6% each year. He says it would take over 80 years for the population to increase by 50% because 50 divided by 0.6 is 83.3 recurring. Kieran's method is wrong. Explain what is wrong with his method. So it is wrong, guys, and the reason it's wrong is he's assuming it will go up by the same amount each time. He's divided 50 by 0.6. Okay, so the simple answer here, okay, is I could say lots of things, all right? I could say that the increase will change each year. I could also say that actually population growth is compound. Okay, either of those will be fine. All right. because the more people I have got, the faster they make more people. Okay, guys, it's that simple. The more of it I've got, the quicker it grows. It's like money. The more's in the account, the more interest I'll earn each year. And then part C, assuming that the population of the UK increases by 0.6% each year, show that the population of the UK each year forms a geometric progression. We've actually done all the hard work here, guys. Remember, a geometric progression means I have a common ratio or multiplier, okay? So what I'm going to do, I'm going to start in 2016 with my population of 6.5 times 10 to the 7, okay? I'm going to multiply that by 1.006, because that's what my multiplier is to get to 2017. So I've then got, it comes out at being 6.5. I'm going to turn it into standard form, guys. 54 times 10 to the power of 7. I'm going to do this again. So I've now got 6.5, okay, and it's 8 times 10 to the power of 7, okay, and this is in 2018. All right, I've got 3 points. I can show there's a common ratio, okay. So my point, I'm going to close this one off, okay. Say each term is multiplied by 1.006 to get, oops, the next one, okay. So it's geometric. And that's it. That's the job done with that question, okay? So yeah, a little bit of explanation there at the end of question 10. And then finally, on to question 11, okay? So this is kind of a bigger problem-solving question here. Anna and Bill share some money in the ratio 2 to 5. Anna gets A to B. Anna gets A. Bill gets B. Carl and Donna share twice as much money as Anna and Bill share. They share the same money in the ratio 3 to 1. Carl gets gets C. Donna gets D. Find A to B to C to D. Right, okay. So this is quite nasty. So I've got Anna and Bill in the ratio 2 to 5, okay? And I've got Carl and Donna in the ratio 3 to 1. The key difference here is, if they're getting some amount, I don't know what it is, I'm going to call it Q, they're sharing 2Q, okay? So what does that mean? Well, that means if I want to write this in one big ratio, I've got to find a way of expressing these all in the same thing. So for example, Anna is getting 2/7 of Q, okay? Bill is getting, and as we did before, we can swap the of for a multiply, so it's 2/7 times Q. Bill gets 5/7 times by Q. Carl, though, Carl is getting 3/4, okay, and his is getting, he's got twice as much money, so it's being multiplied by 2Q. Donna's got 1/4 multiplied by 2Q, okay? So I'm just going to go through now. First things first, okay, if I just turn all those fractions, okay, into sensible things, so I'm going to have 6/4 there. I'm not going to worry too much about tidying it up. Okay, I'm going to have 2/4 there. I can actually get rid of all my Q's because I've now multiplied all the fractions by 2. Okay, so I'm getting that amount right. And now I've got to try and give my answer in its simplest form, which means I need to get it all as a sort of nice ratio-y type number. So what I'm going to do, I'm actually going to look at this. Well, that's actually 3/2. That's actually a half. So I'm going to multiply this entire thing by 14. And the reason I'm going to do that is it's going to turn everything into an integer, because 2 and 7, the lowest common multiple is 14. Okay, so 2/7 times by 14, that's going to be 4. Okay, 5/7 times by 14, I'm not going to be able to do that in my head, so I'm not going to try. So 5/7 times by 14, okay, that's going to give me 10. Okay, 3/2, so that's 1.5 times by 14. Okay, and that's going to give me 21. And I've got 0.5 times 14, 7. And that is going to be the simplest form of that ratio. So it's 4 to 10 to 21 to 7. And that was really quite a nasty question at the end there, guys. Okay, hopefully you found that useful. Hopefully some of those explanations have made sense to you. And thank you very much.